Okay, so if I click now, present now. I'll select the entire screen, is it?
Yes, sir. It brings you up. And then just open the presentation.
I have to select the entire screen.
Yes, sir.
Okay, then how do I?
And just open the file on the.
File is open.
Can you guide sir to open a file?
Which file?
On Google Meet. Sir is telling me that he has opened a file, so I'm just trying to pull him.
Megha, it's better if you do it.
All right, sir. All right, sir. I'll do it.
I think it's this thing. My office here is showing as some. Okay, can you see the screen now?
No, sir. You have not started presenting.
It's okay.
Sir, we'll present. No problem. So just hold on for a minute. I'll just rectify
Okay.
it. Hold.
You got the PPT, right?
So 1 minute. I'll just open my Meet and then start sharing it. I've just, sir, I've received the file. I'll be sharing it soon.
I thought let the students join and you're
But no, for glitches or something that happens.
Okay.
Yeah, because I'll be presenting and I won't be able to see the screen. Sir, can you see it?
Check whether you're on mute.
No, I'm not on mute. Sir, can you see it? Can you see if it's there?
You have to allow me.
Yeah. Megha, I can see it.
Yeah.
It's supposed to be going on and off. So I don't know.
No, sir, it's because students are joining in, so I'm just waiting.
Okay, that second PPT you can. That's an optional thing if they want to do it. If you have the time, otherwise you don't have to present it. You can always share it with them later.
Okay, sir, not an issue.
The second one with the fittings.
All right, sir. Not a problem. I will wait because they'll probably be joining until 9:45. is still joining in. Let's just
Okay.
wait.
Sure, no
Okay,
problem.
sir.
Yeah.
All right. You can see my poster? Okay. Good morning, everyone, and a welcome to all of you for this lecture on water supply and sanitation. So I'd like to welcome Satej sir for this session, and I hope you're all ready with your questions that you have for the session. I'll extend a warm welcome to everyone present here at the guest lecture on water supply and sanitation in multi-story buildings. And I find immense pleasure in introducing Sir as a guest lecturer for this session. Satej Sir owns a firm known as Alur and Associates, and Sir has been associated with Ramaya Institute of Technology for some time now, and he has been taking classes for your senior batches. Some of them are present here in this lecture. So a little bit about Sir. He has done his bachelor's from Manipal Institute of Technology. Thereafter, he did his master's from State University of New York, Buffalo, and he has been running a firm in Bangalore. He also teaches at Ramaya. Thank you, sir, for accepting this request in such a short notice. And we'd also like to thank our HOD ma'am for allowing us to host this lecture in such a short notice. Thank you, sir, and thank you all students for being present on time and being here. All right, we'll move on to the session. So the session will go on for 1 hour, and probably after that, you can ask your questions at the end of the session. Yeah, it's recorded. See if it's gone. So you can start the presentation.
Thank you, Megha, for introducing me and giving me this opportunity to discuss some basics of services. First and foremost, wish you all a happy new year to all your students. Hopefully this year will be a much better year in terms of face-to-face interactions, and rather than doing everything online. There's a lot more things which you miss out when you're doing things online. Talking about this particular topic, let me make it very clear that I'm not an expert in any way in terms of water supply, sanitary, and drainage. That is a specialized engineering subject. I've been only brought in because I think I've got a few years of experience, and I would rather be able to explain this to you more conceptually rather than take you into the technical details of what is exactly water supply, sanitary, and drainage. So given that, you will have to maybe understand, once you understand the basic concepts, you may have to refer to your regular lecturer to be able to get into details of it if it is a subject as a topic. But it is for your design primarily that this can be done without, the basic concepts, if you understand, it can be done without any further inputs. If you understand the basic technology, the way things work, then I don't think you should have any problem in understanding how, whether a single residence water supply sanitary or a multi-story building, what are the concept, what is the theory behind it. Okay, with this particular half an hour or 45 minutes of lecture, I'm confident, at least I hope, that most of you will be able to grasp the concept of it. Okay, and anyway, of course, any questions are appreciated. Here, can we go to the next one? Next slide. Yeah. The primarily thing is water supply sanitary falls under a scope called MEP. Okay. MEP is basically mechanical, electrical, and plumbing services. So there is another thing called SMEP, which is primarily comes under structural design also. So anything which is not architectural, or rather which is connected to architecture but does not fall under the broad category of architecture, basically this building is called MEP. Okay. In this, I will not be talking about things like history of plumbing, where the sources of water are coming from, sewage and wastewater treatment, pipes and specials and other things. I'll be discussing primarily only on the conceptual part of how water supply is done, how sanitary and drainage is done, and maybe if you have time, I'll even touch upon how firefighting is done. Okay. So electrical and air conditioning, I'm not talking about it this time.
Sir, can you hold on for a minute, sir? 1 second.
Yeah, sure.
Sir, I'll switch. I was on. I was not on mute, so I'm muting myself now, and I'll.
Okay. So shall I continue?
Yes, sir. Yes, sir.
Yeah, Megha, I need to see the slide. I can't see the slide there. Okay. So as I said that we are going to be discussing only water supply, sanitary and drainage, and firefighting. So I'm now going to be talking about other things like history of plumbing, where it started from, where the sources of water are coming from, basic things like sewage and treatment, which is in the mass, in the city level, or we're not talking about various fittings and fixtures. If you want, there's another PPT available for that I can share it later on if there is time permits. Okay. So let's move on, going to the next slide. Yeah, so what are we talking about? Primarily, when you talk about water supply sanitary, there are 4 or 5 things which you have to have in mind. One is there's an internal water supply and distribution line, which basically consists of wastewater treatment, the RO plants, the grey water, the recycling plant flow chart. This is how the water basically comes from the main source, that is whether it's Kaveri or a borewell or the corporation water system, how it comes into the building and how the plumbing and the water plumbing is distributed within the building. So this is primarily the plumbing line, internal water supply, how it gets distributed within the building. Then you have external water supply, that is from the building onward, before it comes into the building, and between the source and the building, what are the other activities you have? Those are things like your, you have your sumps, your overhead tanks, bore wells, pumps, firefighting. All these are in between. That is comes in the site area, not within the building plinth area, but it comes outside the building plinth area, in the site area. Similarly, these are to do with water supply. Similarly, you have another thing called sanitary system. So sanitary is basically how the wastewater or the sanitary or the sludge or the sewage is taken out from the internal part of the building. And you have an external sanitary system that from the building to the main manhole or to the treatment plant, how it gets distributed there. The fifth thing is what you have drainage. Drainage is basically excess water which is not connected to your plumbing or sanitary. That is stuff like rainwater and your roof water which is collected. How does that get goes into a main drain? Okay, basically there's a little confusion in terms of what is a sanitary system or what is a drainage system and what is a plumbing system. So basically all of these come under one category called plumbing, but under plumbing you have water supply sanitary, water supply, and then you have sanitary, and then you have drainage. Drainage is primarily meant for the non-sanitary, non-usable water, right? That is taken off directly into the gardens and those kind of things. Next. Okay, so coming to the water supply system, there's a distribution system. If you can see the screen, basically this is just a sketch, but the rainfall, as you all know, basic rainfall is there. That is comes into the catchment area. You have one of the dams which collects basically all the water, and then from there it is pumped into a treatment plant, and then from the treatment plant it goes to a production where they treat with the various chemicals and remove basically the sediments. And then it goes to a production meter where it is distributed through the main lines. This is at a city level. Okay, so from a city level, it goes to a main source storage reservoir tank, and at every stage there are water meters. So there are meters which are connected at the city level. Then it comes into your district layout, and from your layout it comes into your district meters. So then you have domestic meters. So in every site, I'm going to be concentrating only on the connection from to your site. So from your site onward. So at a larger scale, this is what is the city level. But once it comes into your site, primarily the first point of contact would be through the main domestic line, and then it will be through a domestic meter. That is, your domestic line, domestic meter will be specific to your particular site. That meter basically tells you how much of water is coming into your property. Okay. And based on that, you pay the bill. That's about it, right? Next. So basically all the thing what you call is potable water. Potable water is basically water which is usable for drinking purposes, and that will be also, it'll be separated from your unsafe water sources. That means it will not be connected to any other kind of water sources. It coming directly from the Kaveri water in Bangalore, at least from the Kaveri water, or from your borewell onward, it goes directly into your consumption area, right? Then you have the water provision, stuff like plumbing fixtures, devices, other things which are meant for using the specific water. And each of these are designed according to their function and also according to the kind of water pressure which is there. So your maintenance, all your obviously all your plumbing systems should be kept in such a way that it's easy to maintain and it's serviceable condition, right? And you should have accessibility for all these plumbing fixtures so that all the other devices what are there will be in the toilet will be located so that it's easy access. This is just a general note. Let's go on. Next. Yeah. So NBC basically has got a lot of codes. Okay. And as I told you, this is a little technical, so I'm not going to dwell on it too much. But basically the NBC code for you to calculate exactly how much water is required for a building. So they basically calculate number of liters per head per day. So like, for example, if you have a house of 4 people staying, basically you consider a minimum of 70 to 100 liters per day. So if you take 100 liters per day per person, that means you require about 400 liters per day per person. So you normally consider maybe about 3 days of storage, 3 or 4 days of storage. If you take 3 days, that is about 1,200 liters of storage. So you basically design your whole tank size, your sump size, and your piping size, everything based upon the number of people which are going to use the particular facility. Okay. So similarly, a lot of these liters are also flushed out. Obviously, all the 100 liters is not going to be used completely. Most of it is either used in the commodes or in the wash basin. A lot of this is taken out of a flushing requirement. So about 40 to 45 liters per head is taken out. That can be reused and recycled and then again used for other purposes. This is how you save water. Okay, that means the entire 100 liters is not basically going to come into your house and get out of your house, out of which only 45 liters will be getting out. So balance portion will be actually consumed or cannot be reutilized. Okay, next. So, the basic thing, it's a very simple concept. You have everything based on gravity flow as much as possible. Where it's not possible, then we use mechanical devices. So what you have generally is that you have the main water meter which is coming in here. Megha, can I do a cursor? Can I show the cursor? Okay. So you have a water meter, which is where you're getting a main water source comes in. Once it comes in there, it is either goes directly into your sump, which is primarily underground. For a sump is basically a collection area, a collection storage for water, which is depending upon the house and the number of people, the sump size is calculated. So as I said, if you have about, average size about 6,000 liters to 7,000 liters of tank is enough for a single unit residence. Then from the sump, where you have a pump in, it gets fed into the overhead tank. The overhead tank is basically kept on the terrace. So now there are two things. Some people may even have a borewell. So in case you have a borewell, that pump is directly again fed to another tank. So you have two sources of water in this case. Not necessarily in all the residences, but by and large in Bangalore, people do have two sources of water. One source would be the borewell, the other source would be the corporation water or the Kaveri water. So the Kaveri water goes through a meter, the borewell will not go through the meter. Okay, so borewell basically runs on the pump and electricity, that is your consumption. And then that water basically goes into the overhead tanks. And now from the overhead tanks, there are multiple lines which are running out. The general logic is that for each, there's a cold water line coming out and there's a hot water line coming out. So the hot water line basically is a cold water line which goes through the solar line, and from the solar it goes to your individual bathrooms. So assume that you have 5 bathrooms in your house. So primarily what happens, if one bathroom is above the other bathroom, you will have one single line going there. If you have all the 5 bathrooms separated, you will have basically 5 lines coming out from the overhead tank. So if you have a hot water line in all the tanks, that means you'll have one cold water line going to the solar tank, and then from there it is distributed to all the other 5 bathrooms. That it's a little bit more detailed than that, but the basic concept is simple. You have one water line coming to the overhead tank. From the overhead tank, you have one water line going to all the bathrooms, and you have one water line going to the solar. And from the solar, you have one water line going to all the bathrooms again. Okay, this is a very simple concept, and that is the distribution. If you see the black dots, those are the black dots are the ones where the water basically pipes go down to the bathrooms, depending upon where the bathroom is located. Okay, next. So this is another sample of a plumbing layout. So similar kind of a concept where the number of, the solar is much more easily accessible next to the overhead tank. And the red line, what you see is the solar line. And the blue line, what you see is basically the cold water lines. It's the depiction also is just red and blue, most of them, because of thing. And, it's easy to understand, right? So you have 2 different source of lines here. Next. Okay, so that is the layout for a plumbing area. So when you come to a sanitary layout, it is basically that every bathroom or every source where the water goes out, you have an inspection chamber. Okay, I'll tell you what an inspection chamber is. It is basically any point where the pipeline changes, or you have some point where there is a toilet. For it to collect and for it to be ease of flow, you have a chamber which can be opened up and seen inside or cleaned. Primarily, it will be cleaned. So at every point, you will have one inspection chamber, whether even if the toilet is on the above floor, all the pipes will come down to the ground floor, and in the ground, that is underground, primarily you will put these various pipes, which is the red line what you see, and all these pipes are connected to an inspection chamber. In case there's a turning of the pipe, you cannot give a horizontal turn. You cannot give a diagonal turn or a cross turn. It has to be perpendicular. So at every point, you will have an inspection chamber there. And that connects to your, or outside goes to connect to a manhole. Manhole will be basically connected to your main town sanitary system. If you don't have a sanitary system, then you have a thing like a septic tank or a sewage treatment plant. So in cases of large complexes or multi-story buildings, you will have a sewage treatment plant, so that the extra generation effluent which is generated can be reused. Otherwise, in regular residences, all of them are connected to the main plumbing line, sanitary line. Okay, next. So this is a typical bathroom layout. Of course, it depends from house to house and various other factors how you design the bathroom. So primarily you have three facilities there. You have a wash basin, commode, and toilet. I think and a bathing area. Most of you already know about this. Along with this, you may have things like shower. You may have a bathtub. You may have a jacuzzi, and basically this constitutes all the kind of bathrooms. And you may have even a his and her wash basin. It all depends upon the size of the wash basin and all that. And it basically calls to a better layout. The better the layout, the easier the plumbing, and the less amount of cross plumbing lines will be there. Next. Okay, this is just basically a flow chart for inside the bathroom, how a typical piping system works. Now, as I told you, from the overhead tank, you will be having a water line coming in, cold water line coming in. So either it comes through a geyser. In the olden days, everybody used to have a geyser, or even now they have. But primarily now solar is mandatory, so it comes from the solar line. And from the solar line, you have one cold water line coming to the EWC, which is the European water closet. And then you have one, the same line which will continue also to the wash basin. And you have another line also which continues to the shower area. And then you have a hot water line. The hot water line basically goes directly to the shower area, and sometimes it also goes to the wash basin area. So this flow of diagram, the diagrammatic flow which is shown, basically is talking about different pipes coming into each bathroom. So each bathroom will have different pipes. One is a cold water pipe, one is a hot water pipe. So the cold water pipe will be distributed to the commode, the wash basin, shower, and the hot water line will basically distribute only to the shower and to the wash basin. Okay. In some cases, they may not even require to the wash basin. It depends on the individual requirement. Okay. And all these pipes have got different diameters, and they're made of different materials and all that. That I think you can see in the next PPT if there is. You have different sizes of pipes and all that. You don't need to worry about that at this present time. Next. So if you see a typical plan of the plumbing layout, what you'll have is, if you can see the blue line, basically the blue line is the plumbing line. So you have a nearest water supply from the main that is coming from the overhead tank. From there, it gets distributed to the shower area, it gets distributed to the commode, as well as it distributed to the wash basin, right? And if you have a hot water line, the hot water line will come only to in the similar fashion, it will come directly to the shower and to the wash basin. Next. Yeah, and in sanitary, what happens is the plumbing line basically comes through the walls. Okay, it is all concealed behind your tiles and all that. The sanitary line is basically taken below the flooring. So either the toilet is sunken portion, or you will have a kind of false ceiling in the lower floor. In that case, the plumbing lines are taken there. So in the plumbing line, in this case, it is not shown, but generally you have a different plumbing line for the commode, and you have a separate one for your bath, that is your wastewater. Your wastewater is primarily a wash basin water and your shower water. So and when you wash the toilet, all these the bathroom water, the fresh water which goes into the toilet, that is all connected to a 75 mm pipe. That is about 3 inches pipe. Whereas your commode is basically connected to a 110, that is 4 inch. That is called a soil waste pipe, PVC soil pipe, right? The soil pipe goes directly to the inspection chamber. Whereas all the other pipes, all the other sanitary lines goes to a gully trap, and gully trap goes to your inspection chamber. Again, this is in the other section where you talk about inspection chambers and gully traps. There are various types. Again, that you don't need to worry about. The simple common logic is that the commode water, that is the sewage water, sewerage is basically goes to a different pipe, and all your others, nani trap, your wash basin, your urinals if there are, and your shower area, all of them go to a gully trap before they go into inspection chamber. Okay. Next. So this looks a little complicated, but it's not that thing. It's simple flow chart of how a plumbing diagram works in a typical house, which has got a ground, first and second floor. The terrace floor is where your overhead tanks are there, and then this is a vertical cross section of your plumbing diagram layout, which I shown you earlier. So the plumbing diagram layout, which showed you the pipes along the roof, this is a vertical representation of that, and how each pipe comes to various bathrooms or kitchens, or even, for example, it goes to utility areas. So for example, you have a washing machine, so you'll have one pipeline coming down there. You have a garden area, so you may need to have one line connected to the garden area. So like that, you have various things. This is how it's typically done for any particular residence. So this shows you the direction of which the pipes go, and exactly where you require different valves and different fittings fixed there. Next. Okay, this is for a residence. So I think we can just pause here, Mega, and see if there are any questions regarding this basic thing, and then we can move on to multi-story building.
Do you have any doubts? If you have any doubts, please raise your hand and we'll clarify it now. Or write in the chat box.
Okay,
They
we will.
don't have.
Okay,
They don't have.
we will continue.
Yes, sir.
Yeah. So what I talked about is a single residence. Okay. The concept is very similar when you go for a multi-story building. So in a multi-story building, what do you mean? Basically, it's a high-rise building full of number of flats, or it's a commercial building, or it's a hotel, or any of these kind of buildings which require a lot of other. It cannot be a simple system like a sump to water tank and water tank to the various fittings. There are different types of distribution systems which are there. So again, the concept is very similar. It is just that they use different type of technology which is used. Okay, there are four basic methods. One is direct supply. Direct supply from, let's go to the next slide, Amina. So a direct supply system is basically when, it's for low-rise building actually. It doesn't really come multi-story building. This is basically abroad where you have high pressure of water in the main pipe itself. So when you have high pressure water, you don't really require to pump the water up anymore. The pressure itself is enough to take you to your uppermost floor also. So if that's the case, then you don't need to have any other overhead tank at all. It just kind of flows, the pressure is enough for you to do that. Of course, this is not applicable much in India because the water pressure is extremely low. Okay, then you have a direct pumping system where the water is without, again, this is only I use as a pump at the bottom level itself. Directly from the sump, they put a pump, and the pump is directly fed into the fittings of every floor. That means, again, there is no overhead tank. You don't need an overhead tank. Okay. This is also not used in our case because in case there's electricity failure, then this will not work. And there is no gravity thing. So it's a constant use of power is always being used because there's a constant source of pressure which has to be maintained in all these pipes. So again, this is due to, abroad they have a number of places have that where they don't have a problem with power, right? So these two kinds of are not really utilized in India. The next one is, so you have a pneumatic system, hydro-pneumatic system. It's a pumping system primarily. This keeps the thing under high pressure. So it gives a lot of pressure. And again, there is no need of a tank, overhead tank for this. But this hydraulic pressure, of course, most of the bigger complexes in India now have this kind of thing, especially if you go for large commercial complexes or you have hotels where cost is not a factor, and you're keeping the entire building running on an overhead tank. There are a lot of other issues of maintenance and cleanliness and those kind of issues. And of course you get variable pressure because the ground floor is different and your 8th floor is different. So or 6th or 7th floor is different. So the pressure keeps varying. As you go lower down, the pressure becomes higher and higher. So the people on the upper floor will not generally get a good shower or good pressure. So in that case, they use this kind of a hydro-pneumatic system, which basically keeps the pressure in all the pipes the same. So the water pressure maintained for all the fittings and all the floors will be pretty much the same. So it really doesn't make a difference which floor you're on. So primarily, if you see this in hotels, right, because they have staying facilities even on the top floor. So in that case, you will have, even in apartments, you will find this, that the upper floor people generally complain about getting low pressure. So that's why you have this hydro-pneumatic system, which will eliminate this thing, right? Then the fourth thing is the most common thing which we have in India, which is basically for 3 or 4 floors building. You have a pump which basically pumps it to the overhead tank. So you have two tanks. One is the sump and one is the overhead tank. And from the overhead tank, it is all fed to gravity. So again, this is gravity. What happens is there is a differentiation of pressure. There will be a pressure problem right at the bar. They will get good pressure right on the ground floor and the first floor, but you'll get low pressure because of the upper floors. So what they do in this case is they keep reducing the size of the pipe. The diameter of the pipe keeps reducing. This is to do with the basic, hydro technology, whatever they use it. When the smaller the diameter, the faster the pressure. So as you go lower and lower, the pipe diameter keeps reducing. So they keep the pressure is pretty much not equal everywhere, but it is, effective enough. It is effective enough. This is how it is done for whether it's a single story house or if it's done a multi-story house or even if it's an apartment complex, okay, in India especially, right? Yeah. So again, coming back, when you have multiple toilets next to each other, basically the plumbing line is what happens is that you have these cold water and hot water lines coming and they come to common source and they're distributed between the two toilets. So this is when you have 2 or 3 flow toilets, one on top of the other or adjacent to each other. The same plumbing line can be used for distribution between 2 bathrooms. Okay, next. Similarly with the sanitary line. So the sanitary line, what happens is generally it is taken separately, but they are connected outside the building. So if you go to if you see sanitary lines outside, you will see some diagonal pipes. Those pipes are basically connecting from one bathroom to the other bathroom. Again, this, if you see the purple line is more like the commode, that 110 mm soil pipe, and the green lines are basically the flush, the nani trap and the wash basin pipes. So and the bathing areas. That's connected separately. You can also connect them together, both the bathrooms together and do it. But for ease of purpose, it is usually separated. Next. Yeah, so if a multi-story building, what happens is the concept is pretty much same as a residential thing, but the number of inspection chambers and the number of gully traps increase drastically because there is a certain slope ratio which is taken. So for sanitary line, it is basically 1 every 100 feet, you have a 1 foot drop. So like that, and every 20 feet, you have an inspection chamber. So that at any point, there is no clogging, which happens in the chamber, in the pipeline. Okay. Along with the sanitary line, which is going along the building, you will also have rainwater pipes. That means the rainwater roof water which comes in, that is part of your drainage. That comes in and that gets distributed along the site into rainwater chambers, or it goes into a sump, underground sump. And basically that is a sanitary line, and that gets connected either to a external sewage line, or it goes to a septic tank, or it goes to a sewage treatment plant. So if the site is very big, or you have multiple buildings in it, it is normally taken as a sewage treatment plant. This is again decided by BWSSB. They will tell you whether you need to have a sewage treatment plant or not. Of course, if you have the cost permitting, you can do it yourself. Otherwise, it's ideally they will tell you for a certain area, this is you're required to have a certain sewage treatment plant. So the flow diagram is pretty much the same. All you have to do is join all the toilets with a line outside and connect inspection chambers wherever there is a turning of the pipe. And if there is too long a distance, then you make sure that is every 20 feet there's another inspection chamber. That's all. It's a very simple diagram which you have to do on this. Next. Similarly, the plumbing line on the terrace, you have a water tank, and you can see the blue lines and the orange and the red lines. The blue lines, the red lines are basically pipes going to different flats. You see that 1, 2, 3, 4, 5, 6, 7, 8 flats are there in this. So each flat has got maybe 2, 3 toilets. So you have vertical pipes going down for every toilet. So the toilets will get distributed. The pipeline, the blue line, get distributed along vertically. If you have multiple flats, one above the other, then you use the same pipeline with a bigger diameter going for all the toilets, or you can also have separate toilets for each flat. So it all depends upon the builder, how they use it. Sometimes what they have is they have a ring main. They have one ring all around the building on the terrace, which basically gives equal distribution of water. And from the ring, they have taken out to each and every flat. Because if you have a separate line for each flat, what happens is sometimes there is a problem in one of the pipes, or maybe one of the pipes is burst, or there's a problem with the valve, then the particular flat will not get any water at all. So what they do is they have a ring main, and that ring main is given a certain pressure, and that pressure will come to all the flats equally, and simultaneously none of the flats will have any problem of getting water. If at all there's a problem, the entire building will have a problem. Right? Next. So again, I don't want to call this, looks again complicated. It's similar to your flow chart for a residential building, but this, as you see, most of the floors are typical in this. So every floor has got a pretty much the pipes coming down in, and vertically pipes are distributed at every floor, and they get distributed hot water as well as cold water separately. So for each vertical fitting, what you have section, you'll have one toilet or kitchen or utility. The pipes are separated out. Yeah. So of course, bigger complexes, you have a smaller residence, you have a thing called a sump. Whereas in bigger complexes, you have a larger thing called a sump with a fire tank and a pump room. So these are very large areas which require constant maintenance and care, and you have different pumps for distribution. That has been taken, and then also you have the treated water. Sometimes what happens is you have excess water which is coming in. Like when you take a bath, obviously 90% of the water is pretty much goes into the drain. So that goes into a thing called gray water or raw water. Gray water. The gray water is treated, and that can be reutilized again, either for gardening, or it can be used for car washing, or it can be used for back into the commodes, so that the commodes, the flushing system will work in that. So there is a dual piping system. That's what it's called. So you have a dual piping system. The raw water comes in, goes to the overhead tank. It comes to a shower. From the shower, the excess water goes into the drain. The drain goes into another pipe, which is fed into a treated water, goes to a water treatment system. That water treatment system again pumped into another tank on top. That tank is fed directly to only the commodes, and that is flushed out. So it's a little complicated system that way if you go for larger complexes. Right? Next. So coming back to going to sanitary and drainage now. So basically, this is outside the building what we're talking about. So when you have outside the building, you have your main household wastewater which is coming in. That is from your commode and shower and everything like that. That goes into your sewer pipe, which I told you, which is laid below the main road in front of your building, the underground system, right? And you have a secondary system, which is basically a stormwater drain. This is for your rainwater. So the rainwater, you have a catchment area, and the rainwater comes there and then flows into the underground system. This is coming outside your building we're talking about, right? Next. So this is just a graphic showing how a basic pipeline is connected to various parts of the thing. This is a three-dimensional representation of what the two-dimensional drawing which I showed you, right? The working drawings. So you have your commodes, you have your wash basin, and your bath and shower area. And the light gray lines are all the wash basin lines, and that's the plumbing lines which are coming in, the cold water and the hot water line. And the dark gray or there are black lines are basically the underground drainage, which basically goes from the commode and from the wash basin and the bath area. Next. Yeah. So this is just a thing. Basically, it shows what a system is known as, what a drainage system called. So it's basically the conveyance of wastewater from the WC's bathroom and kitchen and thing to the municipal sewer system. It's called as a house drainage system. That's all. We don't need to get into this. Next. Yeah. This is another graphic just showing you how the sanitary line is connected. So if you see the main line, sanitary sewer lateral, which is shown, that connects to the access manhole. The manhole is basically a place where a man can get in. So it's a much larger inspection chamber. The inspection chambers are normally only about 600 by 600 mm, but the manholes are much bigger. They're about nearly 2.1 meter depth, and up to about 1.2 meter. They can be either rectangular or round, and they kind of basically allow with a ladder inside for a person to go in and clean the whole pipeline system. Similarly, you have roof drainage. So the pipes which are there, the rainwater which comes in is basically collected along a filter and then taken. That can be either put into a catch basin, and that may be sent to the main line, or it can be sent to a dispersion trench or a rainwater chamber, for which you can utilize the water again. Next. Yeah. Okay, there are a lot of terminologies which maybe I should have started off with this, but basically wastewater is the water which is used and then becomes waste. Okay, for domestic purposes. It has a lot of other chemical, physical, and biological impurities in it. So that's why it's called wastewater. That is why you call it wastewater treatment. So the treatment of this water becomes basically grey water, and that is converted to can be reused. Sewage is the wastewater coming from the commodes. Okay, that is basically when you go to bathroom, the commode, that is the mentioned sewage. So that pipeline is usually separated out and not mixed with the regular wastewater. This is what I showed you, the two different pipelines. One is 110 mm and one is 75 mm. So these two are separated out. Going to the next. There are a lot of other terminology which the wastewater sullage. Okay, with wastewater from the bathroom, the kitchen, also known as sullage. Then the plumbing system, sewer pipeline. I think most of this you already know. So I've already explained it also, some of them. The mainly thing is the manholes are there, which I told you, and the traps. Traps are basically like a gully trap. And there are grease traps, the other basic traps which are there, which I will come to a little later. Yeah. Next. Okay. This is again a simple system of plumbing for house drainage. That is, I showed you the different types of plumbing for water supply. How the water supply is done. You have the hydro-pneumatic system, you have the direct supply system, and those items. This is basically how the drainage system works. There are basically 4 types of drainage system. Go to the next slide. So you have a thing called a single stack system. As you can see the diagram, what is shown there, you have only one pipeline going all the way down. And this is what happens is, this is a very poor way of doing it. It used to be done earlier. It's not been done there because there's any trap of air or waste or something stuck in the pipe, then there's no way to get rid of it. And remember, all these things have a lot of gas in it because of methane production and all this stuff. You have a lot of gas, so there is a chance of gas getting trapped in. You don't have any kind of vent pipe, so it's a very poorly ventilated system. So generally, this is not in use anymore, but it is just a system which was there earlier. Next. So you have a one pipe system. This is again a separate pipe. If you see that, there's a pipe there which is separate, called a vent pipe. The vent pipe is basically not connected. It's connected to all the fittings, but it goes to the terrace and is open there. So the open thing, the reason is that all the gas goes out, and when there's no air in the pipes, the chance of the sewage going down directly is much more easy. Otherwise, air blockage will be there, and then it will be very difficult for the pipe to get clean, to work properly. Okay, and this is a little complicated system because you have multiple pipes, vent pipes for each and every fitting, which one pipe is going up. It is only one pipe which is connected to all the fittings in the various houses. So it's a little complicated. This also is generally not done. Generally, next. So again, this is a 2-pipe system where your wash basin and your kitchens and bath, all these are connected separately, and the soil waste is separately. So 2 vent pipes are provided, one for the bathing area, the wastewater, what I told you, and one for the sewage area. So there are 4 things. It is generally what we normally use, but there is also another option which is called a modified stack system. That's the next slide. But yeah, so basically single stack partially ventilated system. So here the partially ventilated, if you see, is basically all the pipes connected to a certain commode system are connected to one vent pipe, and that vent pipe goes up. So only the water travelers are ventilated. So either we use that the previous one, we have a stack system, that 2-pipe system, or you have a single stack partially ventilated system. But generally we use the 2-pipe system. That is the previous slide. Let's go to the previous slide. Yeah, the 2-pipe system is generally what is normally used. So the commode, the wash basin, and all these are separated out, and your EWC, your commode thing is separated out. So, and the vent pipe is separated for your commode areas. So you have basically two vent pipes, one for the wastewater, one for the sewage, and you have 2 vertical pipes. Yeah, next. Yeah. So simple things are notes which you need to keep is, it should be as simple as possible. not crisscrossing of lines, if possible, as much as possible, a straight line. All your vertical pipes should be preferably vertical, and horizontal should be as far as horizontal. You can have it at the most diagonal, but that cannot be more than less than 45 degrees. Otherwise, there'll be problem of choking. Okay, wherever there's a change in pipe, inspection chamber or manhole has to be provided. Then sewers should not be laid under the building. So you try to avoid it within the plinth area of the building, because in case you need to clean it, then there's a problem of, one is their accessibility. Second is if there's any leakage, there's a problem of smell and those things coming within the house. Okay. And obviously the pipe should be laid in the proper gradient and slope, because we're talking all about gravity flow. So it should be laid properly so that the chambers will be flow, and the proper flow will take place. Next. So these are basically cross sections of showing different traps and manholes. So if you see the top left-hand corner, what you see is the inspection chamber. Sorry, the thing is general inspection chamber. You have large sizes, small sizes, various different types you have. So depending upon the depth of the outside pipe, that is the one pipe along the main municipal road. Depending upon that, your manhole depth is decided, and also depends upon the first inspection chamber. The first inspection chamber will be the highest, and the last inspection chamber will be the lowest, because the pipes are laid in a gradient. So you have different sizes of inspection chambers and traps. Okay, next. Yeah, this is coming to the firefighting part of it. So let's again pause and see if there are any questions about water supply and sanitary. And Megha, in case I missed out anything, you can just
Students, do you have any doubts? I see that there are a few students from the senior batches too. If you have doubts, you may raise your doubts now.
Megha, do we have time to do the firefighting?
Yes, sir, no problem. We can continue. They don't have doubts, so we can continue.
Okay. Firefighting is anyway not take too much time. We'll just finish it off and then we can open it up. Yeah. So firefighting is something different, although it is not part of your water supply sanitary. It comes under MEP, that is your main mechanical, electrical and plumbing services. And firefighting is basically required for high-rise buildings, and especially in places where a person cannot get out easily. And we do not generally do it for individual residences, except for maybe extinguishers and those kind of things. You have basically three types of systems. One is a fire hydrant system. A hydrant system is basically a piping system again, which is fixed piping, which has water in it all the time, and it is got sprinkler systems throughout the whole building. So the entire building will basically have a fire hydrant system, and at any point, if there is a fire detected anywhere, the fire hydrant system will take off, and then that will sprinkle water in that area. That's a hydrant system. Then you have a fire extinguishing system. Extinguishing system are basically different types of systems which put out the fire. Even though your sprinklers are basically to do with water, your extinguishing systems got to do with various types of gas. So you have this extinguishing, cylinders which are kept out for different types of fire. You have oil fires, then you have paper fires and gas fires. These kind of systems are there. The third thing is an alarm system. Alarm is basically a hooter system and a public address system. So the public address system, the alarm is detected by a smoke detector, and that will send a beeping sound to the entire building, and so that will give a warning signal for the people. So the three types of systems we're talking about. Next. So if you see the hydrant system, this is basically a sprinkler system or a hydrant system. You have a main pump, and the red line, the main line, what you see, these are the lines which are under constant water pressure. And that's why you need these pumps. And these pumps are also, you don't have one, you usually have in two, because in case one pump fails, the other pump takes off, and they keep alternating. so that there's not an overload of one pump. This is 24/7 running all the time. Okay, so because this has to keep the water under pressure, the pressure is kept constantly, and in case any of these different points which are there in every room, in case one of the room detects a fire, there's a sprinkler bulb which basically splinters, and once it splinters, water gets gushing. That's when the pumps start and send additional water to that area. So that will come, the entire thing get flooded area. So this is a very expensive system, and also, but it is mandatory for high-rise buildings. Next. So you have other things like this where you have, in part of the hydrant system also, where you have, if you see the left-hand side, that's an extinguisher. That's a gas extinguisher that you can just, anybody manually can take it and do it. Whereas the right-hand side is a hose reel system. Basically, it's connected to your main hydrant water line. This can be also done without a hydrant, but generally it is connected with to water line, which is separated from your main water supply system. So this particular line will always have water, and you basically take out the pipeline, connect it to the hose pipe, and then you can rush into any room and start spraying the water there. This is an alternative to the sprinkler system. So sprinkler system, as I told you, is very expensive and it has to be maintained. And whereas this other system is a little less cheaper. Is cheaper, yeah. And as you see, it's a very complicated hydrant system, which is below the underground, usually at the fire sump. This hydrant system, this thing is complicated, full of valves and all that. It is also connected to your firefighting, your fire engines which come in. So there'll be one pipeline which is connected to that, so they can pump in water directly when you don't have enough water of your own. Next. Yeah. So fire alarm system is different, as I told you. There's a different system where you have basically smoke detectors, and you have other thing called beam detectors and heat detectors. So there are different detectors which basically detect the presence of any kind of a smoke or fire. Once they do that, they send a signal to the fire alarm panel, and the panel can either, if it's a complicated panel, it will also basically tell you exactly where the fire started. Otherwise, if it's a simple thing, it have a hooter system, it have a beeper system, and it'll start sending an alarm throughout the whole building, saying there's a fire in the building. That's when you have to evacuate the building. That's called a fire alarm and public address system. Next. So that's it, Megha. So now we can open it up to any questions or anything like that. Or in case I missed out something, then you all can.
Yes, so we ourselves have posted a few questions because we feel this is something that they have not asked.
Okay.
So, sir, so these are few things. So, how do you unclog a blocked drain pipe? Is one of it.
Okay.
And the other one is, where are sewage treatment plants located?
Okay.
It's like a multi-story building. Would it be in the basement, and would you prefer it to be on the side, on the ground floor?
Okay. Let's do one question at a time. So the first question is basically how you unclog a drain pipe, right?
Yes.
So
Yes.
is that what the question was?
Yes.
Okay. Basically, if a pipe is drain is getting blocked, there are 2-3 reasons. One is that either it is in terms of the slope and all that. Generally, a drain should never get clogged. Okay. But there are chances it happens because we have people putting stuff into the commodes, which is not allowed actually. Things like, for example, diapers, sanitary napkins, and toilet papers. All these go into the commode, which basically clog up the pipe. Okay, so in case that happens, the general thing is it will either have to be opened up at the inspection chamber level. When you open up the inspection chamber, you will find that the water, the sanitary sewage is not flowing through. In that case, that has to be declogged at that point. In case that also is not possible and there's a clog within the pipe, there are mechanical devices which you can get from the BWC also has it, which they basically insert a kind of a pipe reverse direction, and they kind of unclog that point either with a few chemicals which sprayed in it, or it can just by dragging it out or removing it, it can be removed. So that's a way to unclog the sanitary line. The water line by and large will not get clogged at all. Should not, at least. Yeah.
I think that will be a sufficient answer.
Yeah.
Wonderful. Thank you mentioned now. So then regarding treatment plans and their location.
Yeah. See, treatment plants basically, if you have, as told you, if you have to have a big enough site for that. But there are things, the septic tank is different, the treatment plant is different. A treatment plant is a mechanical treatment plant also. So you have additional mechanical services which have to be linked along with the septic tank or the treatment plant. So the treatment plant is generally located, can be, since it is what called a mechanical device which is going to be there, generally it will be located at the lowest point of the site, because that is where your gravity flow will take part from your inspection chamber to your manhole. It can go to your treatment plant. So it will be located at the lowest point of the site. Okay. And from there, from the sewage treatment plant, if you have a kind of system to bring the effluent back to the site, then it has to be pumped back in. So it is located generally in the lowest corner of the site, for gravity purposes.
Would it be taken to the basement? No, right?
It will not be in the basement, basically because in case of overflow of the sewage or there's some mechanical failure, then basically the sewage will come into your building. Or in case the rainwater flow and your basement gets flooded, then the rainwater will get into your sewage, which makes make it inefficient. So generally, we will avoid putting it into the basement. In certain cases where it's absolutely not, I mean, essential, then it is there, but avoid as far as possible. The sewage sitting on the ground floor level, you will notice it will be a little bit higher than the ground level. It cannot be directly underground. It will be a little bit higher than the ground level. Of course, there are now various systems of treatment plants available which are completely sealed. We have a completely hard PVC sealed, ready to fix sewage treatment plant, which can be completely underground. So that the access to that is only through a manhole, and generally it is access free. I mean, it's like a concealed cistern. Basically, you don't need to go inside it. Basically, you just can do mechanically without going through that. This is of course very expensive, and it's not generally used in India much because our cost is a big factor here. Okay.
Sir, and regarding setbacks, can these come within the setbacks?
It can come within the setback, yes, as long as it doesn't interfere with the movement of vehicles around. If it is a high-rise building, because I told you septic tank will generally come above the ground level. It can come in the setback area as long as it doesn't interfere with the movement of fire engine around it or something like that.
Are there any other doubts?
Sir, I have a doubt regarding the ducting. So when we have n number of ducts, the washroom ducts, and we don't want them to pass through the ground floor, how is that exactly done, sir?
Yeah, see, if in case of multiple story buildings, okay, you have about 8 or 10 floors or maybe even 20 floors, they generally have a service floor. Okay, so a service floor is basically like a floor which is purely dedicated only for mechanical services. So a person can basically crawl in or walk in, especially the height will not be much. It will be only about 2.4 meters or maybe even 2.1 meters. In certain cases, even 1.5 meters. It's called a crawl space. So all your vertical ducts will come and terminate at that point. Not terminate, rather, they'll get bifurcated at that point. So that will not come down to the lower floors. So you can have this, for example, if you have extremely high skyscrapers, okay, if you take something like, the World Trade Center, or you take, Burj, any other bigger, taller building which are more than 50 floors, 60 floors, you will have not only one service floor, you will have multiple service floors. So after every 10 floors, you'll have one service floor. Then again, after another 10 floors, you'll have another service floor. This is basically, it's easy to maintain. That's the only reason they have it. So generally, if you don't want to take the ducts down to the ground floor, you'll have to either bifurcate them, bring them to the outside of the building at the point where you want them to bring them, and then take it outside the building, or you have a service floor. The service floor pipes can be bifurcated.
So while we're taking the pipes outside the building, will that the factor of the beams and the AC ducts, will that be an interference?
It should not be an interference. Why will there be an interference in that? Even if you're
Like if
going
the
outside the
height,
building, you will have a
so if,
duct outside the building rather than inside the building. I mean, otherwise you're going to see all the pipes, no? So you will have a duct outside the building.
so that is when we provide a service flow. What if we don't have a service flow and the fall ceiling is just 1 meter or something? So
Yeah.
that time when we are pulling the pipes out, will that be an interference?
It will not be an interference because your pipes are going to go below the beam. It is not going to go, through the beam. It is going to go below the beam. That's why if you have a false ceiling where the pipes are coming down, you'll have to take the beam depth into consideration and then make sure that the pipe is coming below that. That's why your ducting and your pipes, you have to have a bigger false ceiling there, at least about 1 meter false ceiling that will take care of the beam depths or as well as for the piping.
And so one more, and when the flows are being staggered and the ductings are not aligned, can there be a common duct, a huge common duct created, and all the pipes can be drawn to that place, and that will go vertically down?
That can be done, but the only, as I told you, it all depends upon the flow and the direction of flow, right? So there has to be certain basic slopes given. So if you're going to have a long distance between that duct and the main duct, the 1:100 or 1:200 slope, if it's not maintained, you're going to have problems of clogging there. Because remember, you cannot have a inspection chamber there. That's why we prefer to have vertical ducts as far as possible and take the pipes as lower as down as as many floors as possible before you bifurcate them, because you cannot have an inspection chamber at every floor. Inspection chambers are only on the outside the building, right? Worst comes to worst, if you have a duct going, you can have an inspection chamber directly in the duct right at the bottom, but they're generally not done because in case it starts smelling, then you have a problem in the building. So generally we'll take the pipes directly outside. So I would not recommend you take too much distance between the outside duct and the inside ducts. The distance should be as short as possible.
So, sir, and a question that would probably come across would be that how many toilets would you collect, or what would be the distance be from the common duct and the furthest toilet?
I don't think there's any rule as such for that. As far as the number of toilets connecting, you can go as many toilets vertically as possible. Okay, you can have 15 floors of toilets above each other. That doesn't really impact because the gravity flow will take care of most of the problems. And you'll have to have an issue only in the lowest floor. If you bifurcate it, there's not a problem. When talking about horizontal separation of the ducts, then the distance, generally a pipeline, if you say it has to go, 1 feet down or rather 0.3 down, that means you're talking 1:200 means you have to have it every 3 meters, every 30 meters. Every 30 meters will go down by 0.3. So you're talking about a 1 feet drop every 30 meters. So, the more number of pipes connect, the more chances of getting clogged, the more slope you have to give. We're talking only about a single pipe connecting to about 30 meters away to another duct. So if you have multiple ducts coming, connecting to the same pipe, then obviously either the pipe diameter should be increased or you should have it much closer or much more steeper. In which case it will become 1 in 50 or 1 in 75 like that.
So, sir, in that case, wouldn't the fall ceiling have to be lowered if you're connecting a lot of?
Yeah, it will have to be low. That's what I'm telling you. The closer the duct from the outside to the inside duct, the better for your fall ceiling depth. Otherwise, you will have a problem of slope in the pipes, especially if you're having multiple pipes, toilets connecting to the same duct.
So there's one more question that's come up. They're asking, can recycled water be used for fire tanks or for the sprinkler system?
No, it can't. Basically, because what happens is recycled water is also chemically treated, and you don't want that chemically treated water to go into a fire tank, because that will again have a chance of thing, and it is generally not advisable. So you generally have fresh water for firefighting.
So then, could you explain a bit about core cutting and core cutting done in high-rise buildings? Because there are a lot of people who have used sunken slab and then used core cutting again.
See, core cutting is basically cutting through a wall or a beam. Okay, especially when you have a pipe. So you have a pipe and you're sinking you're sinking the toilet portion, and there's a beam on the external wall. You can make a 4-inch or a 6-inch diameter hole through the beam. Okay, either it is generally not done. Try to avoid cutting through the beams, but in case there's no other option, cut through the beam horizontally so you can take the pipe through. Alternatively, you can cut through the vertical slab also. So that's called core cutting. You cut the concrete slab by means of a special core cutting machine, which basically makes a hole of the exact size of the diameter of the pipe. So the pipe can be easily sent in through that and done there. So in case of multi-story buildings, generally core cutting is avoidable because they will have a duct which goes through and through. If you have a duct which is going through and through, you really don't need core cutting anywhere. The problem is what you have in core cutting, which is coming when you don't have ducts. Then you will end up having core cutting either vertically or horizontally.
So there's one more question they're asking that we see flooding in cities when it rains heavily. What might be the reason for it, and if it is because of improper drainage system, and how can we rectify it?
Flooding on cities is more of an urban level thing. It doesn't really have to do much with plumbing or sanitary, but basically it has to do with low-lying areas being not properly drained off. Okay, there are ways of doing it, but we always take shortcut methods, and shortcut method generally will cause flooding. You have to have basically various kind of barriers so that the excess water does not come in. Even if it does come in, you have to have enough of rainwater and sewage pumps, which automatically start pumping the minute the water starts coming in. So in large basements, you will have rainwater sumps, especially dedicated sumps only for rainwater, so that they have rainwater sludge pumps and rainwater pumps there, which the minute the water gets into the sump, start pumping it out at a higher level. And that will be continuously goes on as long as there's water in the basement. So that will avoid flooding quite a bit. The other ways to do is to have barriers. Basically, you have to have barriers around your site, which is higher or rather which blocks the rainwater from coming in from outside the property inside. You can't do much about water falling inside your property, except for pumping it out or draining it out. But for water coming from outside the property, you have to have kind of a peripheral ring drain, that ring like a stormwater drain around the site, which basically drains off the water directly to the surrounding areas or to the higher level land or lower level land.
So this is regarding the ducts for in case a lot of these pipes are coming together, what would be the size be?
Again, I told you, these are all technical in terms of how you calculate it. The diameter of the pipes, the size of the pipes, the size of the inspection chambers, all these are based upon actual calculations of how many toilets are there. But by and large, a 1 meter by 1 meter duct should suffice to cater to at least about 10 toilets. If you have less than that, maybe 0.6 by 0.6 should be fine. As you go higher and higher, the size of the ducts keep increasing, or rather not the size of the ducts keep increasing. The more number of toilets which are connected to the duct, then the duct has to be bigger. Proportionally, it has to be done. There's no hard and fast thumb rule for that. I mean, if there is, it has to be done through a water plumbing expert, and he has to calculate the kind of duct size which is required. But for a simple 3-4 story building or a 5-story building, I think a 0.6 by 0.6 duct is more than sufficient. If there are multiple toilets coming in connected to one external duct, you can even take a 1 meter by 1 meter duct. And the duct does not have any shape or size. I mean, shape, it can be triangular, it can be rectangular, preferably square or rectangular, but it can be, there's no hard and fast rule for that also.
Sir, could you explain what a sunken slab is and what it does?
Okay. The thing is that most of the sanitary pipes, what I showed you earlier in the presentation, are basically go below the ground. Okay, because we are talking about gravity. So when it goes down to gravity, you have to have the pipes below the commode, below the wash basin, and below the bathtub, below the shower area. So your nani trap, that means your flow trap, and your bath area, your commode, your urinals, all the sanitary whatever is coming has to go below the floor area. So when it's going below the floor area, what you do is generally you sink the slab. That means the slab, the roof slab will not be at one level. It will be about at least 0.6 or 0.45 below the regular slab. So when it is 0.45 below the regular slab, what you do is once the RCC slab is cast, you do the sanitary line fittings on the sunken slab, you sink the slab, then you fill it up either with cinder or brick or concrete. You fill it up and then bring the toilet in the same level of the other rest of the concrete slab. So all the pipes are taken in concealed manner in the sunken area. The problem with this is that in case there's some breakage of some pipe at a future time down the time, it's very, very difficult to repair it. So generally in public buildings nowadays, it's avoidable. Sunken slab is avoidable, but age-old practice was to give sunken slabs. Nowadays, what happens is they generally give a false ceiling, and you do core cutting in the slab itself, and the slab is cast at the same level, and the pipes have gone to the lower floor, and you have false ceiling to cover those pipes. So in case there's any leakage, you can repair the pipes directly from below. You don't have to worry about breaking the tiles, removing the concrete, and redoing the pipes. So the sunken slab is basically a slab which is lower than the main slab, and the pipelines goes through that, and it is filled with cinder or brick. I think it's easier explained through a diagram, but I don't have a diagram with me on.
So when the sunken slab is of 0.45 depth and the dia of the soil pipes is 6 inches, so I think we'll have to give the sunken slab more of the depth for the slope as well.
The dia of the soil waste pipe is not 6 inches. It will usually be about 4 inches. Okay. Your 6-inch pipe will only come at the connecting from one inspection chamber to another inspection chamber. I'm talking about horizontally. Whereas in the bathrooms, generally the diameter is not more than 4 inches. And even then your sunken slab is 1.5 feet. Okay, you're talking about 18 inches. If you're doing it in meters, then it's 0.45, whereas your diameter pipe is only 0.1. So there's more than adequate space for that. And worst comes to worst, you sink the slab a little bit more. You sink it to 0.6 if you feel that's going to be a problem.
Does anybody else have doubts?
So what is the depth of sunken slab again?
It varies. If the toilet is very large, the pipe has to go a long distance. Then you need a bigger slope for the pipe. You go for about 0.6. If it's a standard size toilet, 0.45 is more than enough.
So nothing less than 0.45?
Nothing less than 0.45, because your flow trap itself is about 0.1. Okay, so you take the highest point of the toilet, that is your flow trap, that is a nani trap. From that is your, actually, if you look at a toilet, the lowest point of your tiled floor is your nani trap. From there, it has to go down at least 0.1, and then from there, it has to go to the external wall in a proper slope. So if you look at it all that way, I think 0.3 is cutting it very close because of the concrete thickness and pipes and all that. 0.45 is more than comfortable for a reasonable sized toilet, and then 0.6 is good for a large sized toilet.
Okay,
so
sir,
what
thank
can
you.
be done if we need to run a beam below the sunken slab, if the condition is like that?
If your structural area is good enough, he will avoid a beam in the sunken slab area. Generally, it is not done. I mean, because during the planning itself, the structural engineer will be able to take care by running a parallel beam and kind of supporting one beam on top of the other beam. You can avoid a beam in the center of the duct, center of the toilet.
Okay, good morning, Satish sir.
Good morning. How are you?
Yeah, fine. See, you have given very useful information now. It's not just useful for students, even for an experienced teacher like me, and also tried a little bit for practice and all, hand in this in practice and all. And I'm sure the tips, the especially these plumbing design tips and all, and water supply, I mean ideas, they are very much useful. In fact, you have really updated this information now from up to I mean now, and also the way how these connections are made, and how these say especially these inspection chambers are taken, and really good information. I'm sure our students will be largely benefited by this information, and also for us. So thank you so much for, in fact, the way you have explained in a very simple and a lucid style is really effective. I'm sure we'll all be benefited by that. And on behalf of SOA, of course, this Megha and team will thank you separately. From my side, I'm thanking you for a very good guest lecture with very good information. Thank you, sir.
Thank you. Thank you very much. Good to know being useful to somebody.
Any more doubts? I hope not. Because we are ending with the session.
Megha, there's other PPTs there. I would suggest you just share it with the group if they want. That is nothing to do with it has to do with water supply and sanitary only, but it's basically got to do with the various types of fixtures and fittings and the types of pipes and the types of traps, explanation of the various traps. So that talks about that. So if in case they're interested in getting into a little more detail, you can share that other PPT with them.
Sure, sir. I'll share it with them.
Yeah.
Aditi, are you?
Yes, ma'am. So hello everyone. I'm Sayati and I'm going to present the vote of thanks for this session. I would like to thank our speaker, Architect Satej Alur, for today's lecture. It gave us a lot of insight into the topic of water supply, sanitation and drainage, and especially in a time when we cannot go on site visits to see such things in detail for ourselves. These lectures are very important for our knowledge and education. So thank you very much for taking the time to give us extensive information on this topic. I would also like to thank our principal, Pushpa ma'am, for giving permission to organize this lecture, and also to Megha ma'am and Sheetal ma'am for conducting it. Thank you to all the students present here for paying your attention and learning and being so inquisitive and asking for even more information and taking your time to learn all this. So thank you, everyone.
Thank you.
Thank you, sir. Thanks a lot, sir, for coming, even though you're not well.
Okay, no, I'm fine now. Thank you.
All right. Thank you.
Okay.
We'll
Bye-bye.
be closing the session. Bye, sir. Students, you may leave the session.
End the record.